Welcome everybody to our ME seminar. I'm Michael Landy, Assistant Professor in ME. Today we have a guest to continue our series of speakers who have been involved with the Keene Entrepreneurship Education Network. Dr. Ken Bloemer is active in Keene at the University of Dayton. He is the director of the Visioneering Center at the University of Dayton School of Engineering. So Keene supports pedagogical innovations that support the development of entrepreneurial mindsets for engineering students. Dr. Bloemer will share today an in-depth project to capture stories from practitioners to present as case studies in the classroom. This work is supported by Keene and an example of some open source resources that are available throughout the network. So Pierre and I have been visiting with fellow faculty to share resources and our onboarding with the Keene network. So many of these resources are centered on the Keene website, engineeringunleashed.com. So Dr. Bloemer has curated these case studies and will share more information about his work today. So thanks, Ken, for being with us.
Absolutely. Pleasure to be here. I haven't been out to South Dakota in a while, but I need to get back. It's been a long time. So yeah, we've been a partner with Keene for quite a while. And I'm going to start with a short story on entrepreneurial mindset. So let me share my screen, and then we'll jump into case studies and why I really like case studies. Actually, I'll start with case studies. So I don't know about you, but when I was in my undergraduate, master's, and PhD work, I love real world stories. And they always capture my attention. You know, I'm okay with the theory and everything, but show me why I should care. And so I love real world stories in the classroom because I learned so much from them. And that's where I think case studies really play a big role. You know, and we've all seen the traditional case studies like the Tacoma Narrows Bridge blowing in the wind and crashing to the ground and those kind of things. And those are all excellent ways to learn. But we're looking for other case stories and that aren't just based on failure, but based on success also. So everybody has probably heard of the 3 C's of the entrepreneurial mindset. Curiosity, everything begins with curiosity, because if we weren't curious people, we'd still be living in caves, right? So we need that baseline curiosity to gather all the information in our brains so that we can make connections, putting things together. There's a new material over here, and we're doing this. I wonder if that new material could help make my product more earth-friendly or perform better or do whatever, so that we can then create value in the world. Because what good is it if we don't, what good is a new innovation if it doesn't create value? So one of the greatest things about being in the network is the ability to meet people that I would have never normally met. I wouldn't have met you folks if it wasn't for the Keene network. So a while ago, I met Dr. Glenn Gaudet. He's a professor. He was a professor at biomedical engineering at Worcester Polytechnic, and now he's at Boston College. But Glenn is super curious about everything related to cardiovascular. You know, he's focused on rebuilding damaged heart tissue. He's focused on rebuilding new tissue. So he's insanely curious about everything related to the heart. And it's his life's research, right? So one day, Dr. Glenn goes out to lunch. He's out with a colleague, and he's having a spinach salad. No big deal, right? But he kind of zones out, and he's looking at his spinach salad, and he picks up a leaf out of his salad, and he's just focusing on this spinach leaf. And his colleague is like, Glenn, what are you doing? And Glenn holds up the spinach leaf to his friend and says, what do you see in this spinach leaf? Put yourself in cardiologist kind of shoes. And of course, what he sees is this super rich vascular network in this spinach leaf. That's the aha moment. That's the connection moment where he realizes that cardiovascular networks on a cellular scale are available everywhere in nature. And so he gets very excited about this, because this network is something we could never manufacture on this level. So he gets excited, he goes back to college and goes back to his university, and he picks up some spinach leaves along the way at the local grocery store, and he makes more connections, and he meets with the biology department, and he figures out that wow, we can perfuse this spinach leaf with a certain type of detergent, and it removes all of the cellulose green leafy material. And now he has a scaffolding material that he's now profusing with blood. And he uses this as a scaffold to grow new heart tissue on. And they're also using this scaffold to place on damaged heart tissue to help revascularize damaged heart tissue. So talk about value creation. I mean, phenomenal value creation. And it also begins with curiosity, leading to those aha moment connections, and thus creating lots of value. And I've been thinking about this in 100 other stories like it. And the more I think about it, all new to the world innovation is born of curiosity, connections, and creating value. So I just like sharing that story and a million others like it, because I think it helps. This is the type of engineer that we need. And I think one of the ways we can help spur this on is find real world stories of entrepreneurially minded engineers and other people and bring those into the engineering classroom. Plus, the stories are just phenomenally interesting. So, EM case studies. I'm gonna give you just a brief look at just kind of the array of case studies that we have. So we've all looked at a block on a plane, right? I used to get so tired of blocks on a plane. I'm like, can't you at least bring in a block on a real plane so we can, so we can visualize it better? So I think it was 2 years ago, I was just on the internet, and let me close this for a second. And I came across this mug. It's called the Mighty Mug. I'm gonna stop my presentation just for a second. I'm gonna put my camera. So this Mighty Mug is interesting because I have one in front of me. So can you see my Mighty Mug? What's interesting about the Mighty Mug is that it lifts like any other mug, but it's called Mighty because you can't knock it over. So it's bizarre. I can stick it on a whiteboard and it'll stick sideways. I can stick it on a window and it'll stick up, but it lifts normally. So I thought that was quite intriguing. So I thought, wow, wouldn't it be interesting I'm going to go back to my presentation. Wouldn't it be interesting to bring this into the classroom? So I incentivize faculty by giving them a UD logoed Mighty Mug. Wouldn't it be interesting to bring this into the classroom, have some fun with it, right? And then figure out how much force does it actually take to knock over a Mighty Mug? And the reason this is interesting is because it's a real world problem. You have to make assumptions. There's also some really funny YouTube videos that goes along with it to bring some joy into the classroom. And then you can figure out how much force theoretically should it take to knock over the mug. Then if you're really motivated, you can actually instrument this to figure out how much force it actually takes to knock over the Mighty Mug. And then you can have a rich discussion in the classroom about why the calculation is slightly different than the actual force it takes to knock over the Mighty Mug. And then furthermore, when we get into the case study, there's an amazing story about the gentleman who invented the Mighty Mug. And he was at a very nice restaurant with his young kid who kept knocking over the glass. And it happened over and over again, spilling milk in this fancy restaurant in California. And he said, I'm going to create a solution to this problem, because they just left the restaurant because he was so embarrassed because it happened 3 times in a row. But the story of the creation of that innovation was really interesting. And then the whole idea of getting a patent or a series of patents, and then I think he was knocked off like 55 different times. It was crazy how many times he was knocked off, and the strategies he employed to help protect his intellectual property. So great stories there. I imagine most of you are familiar with design thinking from IDEO, the probably the most world-renowned design firm in the country. And so we met with one of the 3 founders of IDEO, Mike Nuttall, in his home. It was really great. And he was explaining his perspective of this. And one of the things that I found super intriguing about Mike Nuttall's story is he says almost everyone no one really understands the front end, the empathize step, because most people think it's just like going out and visiting with customers. And he explains it's so much more than that. That first step is critically important. It is understanding your customer, but it's also about doing competitive research on other products, going out and talking to customers about what they like and what they don't like about the competitive products. And he gives a much deeper understanding of what this is really about. And then he takes the original Microsoft mouse, which I thought, oh, you're really going to use that product as an example? But it turns out to be really intriguing, the process of developing the original Microsoft mouse and what really differentiated it from everything else that was on the market at the time. Another example, I imagine everybody knows Jamie Heineman from Mythbusters. We went out to focus on his new drone killer, which was a project he did with the Department of Defense to, if a bad guy sends a drone into like a stadium or something, Homeland Security and others wanted another drone that could take that drone out without, shooting bullets or something, without explosions. So of course, Jamie Heineman created that and was pretty awesome. But when we got to his shop in San Francisco, he's got so many cool things. So we just created a compilation of really interesting things. In the lower left is his, this is a, what is it? It's meant for putting out forest fires. So this repurposed military vehicle is filled with different kinds of water, it could be, but other things that can go in and go through forest fires and put out fires at their point. Really interesting. And then if you haven't seen the lead balloon, that's a really interesting story too. But there's tons of good stories in there. And it's just talking about his philosophy and inventing, and it's an intriguing story. I don't know if I've always been intrigued by that stupid yellow line in football. And it's so much more than the yellow line because, it's not projected on the field. It doesn't go over the top of the players, but it's perfectly underneath the players as if it's a real, line appearing underneath the players. But it's in fact so mathematically based and optics. There's so many things happening there. And there's so many other things that part of being an entrepreneurially minded engineer is once you have something really cool or really a value creating, where else can you apply it? So they took this company, Sports Vision, took the same technology and then applied it to sailing. But in sailing, the big sailing races around the world. But in that case, they project the grid lines so you can actually see which sailboat is winning, or to NASCAR races where the little flag appears on the car. And how that's done is so fascinating because regular GPS isn't nearly accurate enough. So really compelling story there. A Villanova grad created an all-wheel drive motorcycle. And it's much different than just two wheels being driven. It's truly all-wheel drive, so that the front wheel kicks in when it's needed. But what's really interesting, this started as a senior design project, and it grew into his passion. He makes these motorcycles for the military. They're real easy to ride. They're very robust. He's now doing electric motorcycles and doing lots of really cool things. So from an engineering perspective, there's all kinds of torque things that are really so there's sections on just the torque challenges. So, and the drive mechanisms. So lots of mechanical engineering built into this bike and built into that case study. And one last one here. This is probably my favorite, is the Skycam. And I'm going to show you the Skycam, but the Skycam is brilliant. And the story of the Skycam's creation is equally brilliant. And we have several others, and we're in the process of making more. But let's go in and take a look at what some of these case studies look like. If anybody has any questions while I'm pulling this up, I'd be happy to answer them. Okay. So I'll give you a look here. So this is the Skycam case study. I'll just give you a look here of how we build these case studies. This one's a little long. This one's 54 minutes, but I also want to show you one other thing. we realize that some students and some faculty don't have a 54-minute attention span. So we also have this, so when you breeze through the SkyCam case study, we also have the introduction, we also have these sub videos. So we've broken the SkyCam down into 36 separate mini videos. So if there's something you really want to focus on, you can just grab the videos that you want for your classroom. But let's take a look at the SkyCam. So we realize attention spans are short, so we do our best to make these really compelling. These can be used as a homework assignment, or they can be done in class, preferably, in my opinion. But so let's take a look at the start of SkyCam.
When you see a camera angle like this, watching a sporting event, you think it's pretty cool, right? Well, imagine how much technology went into designing the camera system that can capture these images. It's called SkyCam, and it was invented by Garrett Brown, a revolutionary cameraman on films like Rocky and Indiana Jones and the Temple of Doom. His innovations have changed the way movies are filmed for the past 35 years. But SkyCam caught people's attention at the 1996 Olympics. And by 2003, the NFL started using it for their TV games. But how does SkyCam actually work?
It was pretty clear it had to be on wires. The lines that ran to the camera should clip to something called the gimbal. The gimbal to make sure that whatever's supporting something doesn't affect its angle. So we clip 4 lines to the gimbal, which is at the center of gravity of the camera on the bottom, and a weight. Each of the lines goes up to the highest place in the corner we can find, and over a pulley and down to a motor.
I flew to Santa Clara, California to tag along with a working SkyCam crew as they
I'm going to speed up just a little bit here.
instructions. Once they're programmed into SkyCam's computer brain, it stays inside the box at all times. Okay, so Josh, you're going to show me how a SkyCam works, right?
I'm going to do my best.
Okay. So what do you have here?
We call this the PCP, Pilot Control Panel. And this allows me to move the physical body of the camera.
So I'm not going to bore you with all those details now, but basically there's huge safety perspectives here. There's controls perspectives. There's just so many engineering issues built into this that it's quite fascinating. Let me bounce ahead here to some other things.
As a customer, I still have that telex.
So this is a different invention that he actually talks about several inventions. This is the invention. It's the first time ever. It changed Hollywood for the most part. It's called the Steadicam because you always had to put a camera on a rail system or up in a crane to have it smooth move along with the person. So this is his wife, and he's running with a movie camera, but it's on the Steadicam that he wears over his shoulders. The camera doesn't bounce as he's running along. So it's what they filmed Rocky running up the steps with. And
what I did was, in a nutshell, expand the physical structure of the camera so its center of balance was obtainable rather than in the camera. In other words, add batteries or monitors or something and drag that center of balance out of the camera. Put a gimbal.
So what's really interesting, I'm not going to bore you with all these details, but when he's talking about the SkyCam, there's so many unforeseen things that you need to look out for, because they've had several instances where the football teams just start throwing the footballs at the camera. And so it has to be intentionally built to withstand, a quarterback throwing things at the camera. It has to be super safe. You have to be sure that the camera isn't, over the top of people other than the players on the field, all kinds of issues. But what's really fascinating, when I have students in our senior design capstone projects, they want to jump right to building things, cutting metal and steel and wood and whatever they're doing to start making things. But the prototyping story for this one is fascinating, because once he came up with the idea of we need these 4 points with wires, and the wire, and it's just the cables in and of themselves are fascinating, because they used to be stainless steel and they would use microwaves to transmit the video. but then they got more sophisticated, and now there's a fiber optic cable inside of a Kevlar belt, and it's only 1/10 of an inch diameter. And so the video is going through the wires. But the way that the first prototype of this is he called up 3 of his friends to his house, and he gave each of them a spool of thread with a little winder on it. And he put each one in the 4 corners of his kitchen. And they tied a key, just a regular household key, to the center of each of the 4 threads. And then they practiced winding up and letting out, and they demonstrated to themselves that they could make the camera go up, make the camera go down, make it go around, and do figure 8s. And from that simple activity that probably cost $2 or $3, they figured out a lot about what the controls have to be like. And they just did so much. And I think it reinforces for our students that you should do back of the napkin prototyping. You should do down and dirty and cheap prototyping before you start, cutting metal and doing all those other kind of things. So there are so many lessons learned in here that I just find it fascinating. That's why this one is a bit long, but I'm going to see if I can capture a couple of other things in here. And so, as you can see, this one's a little long. So after you zip through it, faculty can feel free to grab any portion they want. I'm looking for another one. There's also, I can't find it right now. I'm going fast. Let's see what that is. Oh, it's a different one. There's also, I'm sure you've watched the Olympics and seen the diving competitions where the divers are going off the board. He and his team also invented the dive cam. So very difficult, because when you see the diver go off, the camera drops with the diver down a tube over here, but it drops by gravity, which is just how the diver drops. And then it goes underwater, but it stays with the diver. So this is the first time you can see a lot of action happens under the water. You can tell a lot about how successful the dive was under the water. And there's so many other things that he created, and just, I find it inspiring just to watch this guy. So let me see if there's anything else interesting here. And then we get to talk to the engineer, who talks about all the challenges with the design and different things. So we can focus on this from many, many different perspectives. Any questions on that one?
This is Micah. I'm curious how you set this up for students as to what they should watch for or take note of. How do you encourage them to connect this with what's in the classroom or reflect or whatever?
Yeah, so that's a great question, Micah. This one is a little more open-ended. We have the other one, like the Mighty Mug. This one was very specific to statics class, so it's built for a statics class. This one has so many other attributes. We're just trying to put it out there, and we're hoping that faculty will see where the fit is. What we learned is that, so we have another one for biomedical engineering. I'll show you that one in a minute. But so we're trying to build them specifically for classes now. This one was a little bit more wide open. Be great for a senior design class, those kind of things. But right now we're developing another one for a water engineering course, which most of our civil engineering programs have. And this time we've gotten a lot smarter. So we're working with a faculty member who teaches water engineering here at the University of Dayton. And that course is a similar course to what most universities have. So we're working with her and the entrepreneurially minded engineer is the star of the case study. But we're developing it specifically for that course. And we're making sure to include things that are key to that course. So, and it's going to have lesson plans built into it. So back to the Mighty Mug, it has homework examples built for statics, and it has worked out problems built for statics. This one's a little more wide open. So great question. Did I answer that for you?
Yes, yeah, thanks.
Great. Other questions? Okay. Here's another one. This one is for Let me expand. So let me show, this one's great. Here's the introduction. Whoops.
And he is the unlucky recipient of primary adrenal insufficiency. We as a family have been dealing with this for 9 years. He started to scream and he said that his legs were hurting. I just knew that, oh my gosh, his heart cannot perfuse blood to his legs. That's what the pain is. Busted through the double doors into the pediatric ER. So they called in a pediatric cardiologist. Then she grabbed my hands and she looked deeply into my eyes and she said, had you waited 15 more minutes, this would have ended differently.
It's just tired. You never know what's gonna happen. Like you could throw up or pass out anytime. You never know if you're gonna have a crisis. You have to always be careful what you're gonna do.
The challenge for me now is that he is growing up and it is time.
So what we're doing is we're clearly establishing the need. So there's a medical condition known as adrenal insufficiency, where people who suffer from this, their bodies go into crisis, and if they're not, if they don't get cortisone into their body, they will die, unfortunately. And so the current state, the practice is that you have a powder medicine and a liquid, and you have to mix these together in a very specialized way. I think it's 12 or 14 steps you have to go through, and then fill a syringe and inject yourself. Well, obviously the person that's in duress, the person with the adrenal insufficiency can't do it. So the caregiver has to do it. And the caregiver is typically a mother, father, other family member, and they're under duress because they know the severity of this situation. And it's just terrible. So this young lady, let me zip ahead. This young lady, her brother and her suffer from adrenal insufficiency. And her mission is to create an EpiPen-like device. And so this will be great for any biomedical engineering course, because it gets deep into the regulations and what you have to do and the challenges and fundraise, all those kind of things. And what was I going to say? So it sets up the challenge. It sets up the need, gets into the challenges, and she has lots of great stories as a young female entrepreneur on a mission and trying to get this done. And she's just about ready to come out to market, I believe. So she's got prototypes with her and she's showing various things. So it's just a very compelling story that will certainly be an eye-opener for anyone who's getting into the device industry or moving that way, to understand all the complicating factors into bringing a medical device to market. Let me see what else I have for you. I have my case studies here. And I have another one here. Trying to find just an image. So Glide, this is, students like beer, so you generally like this story. Let me just open the full case study. Trying to get to some images here. So this story begins with, these guys are from MIT, and they started another one as a capstone project, and it deals with a bunch of bars in Boston, and the company that delivers through Budweiser, sponsored by Budweiser, and the people who deliver kegs in the middle of the night, kegs of beer and other soft drinks and stuff. In Boston, all the bars store everything downstairs. It's a very crowded city, right? And so these guys are bringing 1 keg or 2 kegs of beer down flights of stairs at night. And it's brutal. There's lots of injuries. They get incentivized by going faster and making more deliveries per hour. And so it's a very dangerous business and whatnot. So in an effort to fix this, this project was established, and they came up with a very unique design here, I forget the name, well, they call it glide, where there's a mechanism that gives you controlled braking, and it helps you literally glide the beer down. But what's really fascinating about this story, they do a really excellent job of customer discovery. Before they put any designs on paper, they spent hundreds of hours riding in the middle of the night with these delivery people. And it was so insightful what they learned, because these guys are pretty particular. They're proud of their hand trucks, and they all have their own. Some are all spiffed up. And to get them to try anything new, you have to really understand who your customer is. So they did lots of very cool things, and they have before and after videos. Then they figure out there's so much less stress on the individual's back, and they have data to support that by instrumenting people. And it's just a wildly successful project. They of course carried it far beyond senior design to make it successful. What else do we have here? Go back a little bit. So we have, again, Christini. I'll just show you a brief portion of this one. This is the all-wheel drive motorcycle, where again, we start with trying to build excitement at the beginning.
The all-wheel drive motorcycle concept started back as a senior project at Villanova University. We had to do a project that would actually build and design something. And I'd always been into mountain bikes and always been into.
So this is the.
Why they ended up picking the bike up, and now we actually have bikes with the U.S. Special Forces, UK, Jordanian, UAE, and some others. And it's been an exciting time, because this is a technology that allows them to do things that they otherwise couldn't do. Going beyond that, we
Speed up a little bit here. I think that's his first prototype, if I remember well. And here we're sitting in.
trying to take this idea that I had.
So this is all about bringing an idea to market. But when he gets into the technical stuff, this guy is a brilliant engineer. You know, he's talking about torque steer and lots of detailed. He's talking about material selection for gears. So there's lots of material properties and things built into this one. Again, this one wasn't for a specific course, but I think any mechanical engineer who breezes through this will find lots of opportunities to use this in the classroom, and lots of challenges for students. So let me stop that share for now. And so thoughts, questions? Does it look compelling?
Can you hear me?
Yes.
All right, so Pierre here. So
Yes.
so you've shown us some videos, which obviously go with the case studies. Could you give us an overview of the structure of the case studies? Are they all video based with some accompanying documents?
Yes, they're all video based, because that's what students tell us they like the most, and they are all placed on engineeringunleashed.com, if you're familiar with that platform. And there are cards associated with each one saying this case study is most. Let me show you one. I had it pulled up here. Let me start sharing again. Sorry, I meant to show that. Back to my desktop here. Sorry. Engineering. Yeah, so let me show you what a typical looks. So when you type in EM case study, that's how I've tried to label those. So here's my,
Is there a card deck with all of them in it?
there will be very soon. Yeah, there will be very soon. So here's the Mighty Mug one, for example. So there's a description, talks about what it's for. There's learning objectives for each case. And then the videos are here. And let's see, there's an assignment. Let's see. So here's the activity handout. Here's the homework assignment. Here's the solution here. Yeah, and this one is very specific. I'm sorry for scrolling so fast. Summary, force calculation for statics or physics 1, while also learning contemporary EM skills, entrepreneurial mindset skills. So that's what they typically look like. But now our new model is to create these, again, with a faculty member actually teaching the course so we can make them more specific to an individual course, like this one was.
Would you say most of the case studies you have are like geared for like one class period, or is it like a module that goes for a couple of weeks, or?
Yeah, so it's totally up to the individual faculty member. Some people, like if you were teaching a class around torque, you could just go to the Cristini all-wheel drive motorcycles and you could just grab that video on torque steer. Or you could assign the case study as a homework assignment and have the students watch it. Now, I have found that students like to watch things on 2x, but you know, they still get the gist of the idea. But it's still a rich learning experience to go through, because it gives you, rather than just, you know, focus on the engineering mechanics, you're focusing on the opportunity to impact skills in the Keen framework. But excellent question, Pierre.
Can I get one more?
Yeah.
So at the beginning of your talk, you mentioned, I think you kind of off the cuff said preferably in class instead of out of class using these case studies. Could you talk a little bit about why?
Sure. Let me stop sharing here. My preference is for in class. I get pushback from faculty, of course, because it would take a class period to go through a case, but because there's a lot of lessons learned from learning from these real stories about doing real world design. And I think it's worth stopping and having discussions. So I mentioned the SkyCam and how it was so brilliantly prototyped for $3. And going through that and then talking with students briefly about it, I think is impactful, because, you know, we can do so much, we can learn so much for little, that, you know, that to me, that's a very important lesson. So if I was seeing people, you know, doing back of the napkins design and then going down to the shop to, you know, to produce a 3D full-fledged prototype of something, I might show that to say, you should think about how you can prototype this out of cardboard before you want to go down and cut things, right?
Thank you.
Sure.
So this is Micah again. I used the IDEO case study in my sophomore product development course. Yes. And so very early in the semester, we watched the Nightline shopping cart video, right? And it's a very slick thing. Nothing ever goes wrong, right? And so it was interesting to have the voice of Mike Nuttall give some context to that particular thing. That he's like, yeah, it was not successful because you don't see these things, these shopping carts that we redesigned out in the world. But it was also interesting to and this is a benefit of a 2-hour class, of screen this and then discuss it. And there were all these pearls of wisdom that students took from this talking head walking through a number of their experiences to me that were just like so fascinating, and it seemed to imbue some mileage or experience of going through the design process vicariously, right? It's like I think the thing that sticks with me a little bit is, oh, they had the perfect design for a mouse. They just make it a square and it would be so resolved. And then it's like, oh, good thing you prototyped that because you can't figure out without looking at it which side is up.
Right,
And so
right.
it's the hubris of ingenuity and genius, the lone genius, right? And so, like you're saying, like back of the napkin prototyping, right? It was some things that I think some of the students internalized, and it's just such a interesting, like, efficient use of, like, they listen to someone else telling a story and they internalize that kind of judgment.
Right. It's interesting that you bring up the IDEO shopping cart because we had a discussion, and part of that is included in the video because he talks about how embarrassed the company is that they use that so many universities use that video because it was actually a terrible design idea, their end solution, because it was prototype based off of super shoppers, people that shop for other people. And he explains how that design, if it was implemented, would be terrible because all the carts would be left in at the beginning of the aisles and people would be shopping with bags in the aisles and it would be a disaster. So it might be interesting to look at that and then show that to your class.
Right. I mean, I think that's some of the takeaways of like, oh yeah. Like there's the introduction to the design process and then there's the kind of reflection on what actually is at a more meta level of a
right
expert way to go through it.
The other thing that he talks about is Amtrak. Amtrak hired IDEO to make more comfortable seats for the trains. And like IDEO said, well, let us study your process first. And they looked at the entire process from ordering your tickets to getting on the train to going to your destination. And they quickly learned that the problem isn't uncomfortable seats. The problem is their whole process of getting tickets and getting there and getting on the train. And so they totally refocused the project. And that's the importance of the empathize step up front, because they were solving totally the wrong problem. So I guess I'm a little biased because I'm there in the room for the stories, and but so you know, we have a lot of work to do on making the case studies more faculty friendly in the classroom. They're probably more entrepreneurship friendly at this point. And I'm actually meeting with the foundation next Tuesday here on campus to discuss how can we make these better. So.
This is to Visioneering. I have a question.
Yes.
So, I was curious how you prepare your homework questions or assessments to evaluate how they really grasp the entrepreneurial mindset.
I couldn't quite hear that as well.
So let me repeat it. She's a little far away from the microphone. So curious about how you have homework assignments or other things to evaluate students' understanding of the entrepreneurial mindset?
Yeah, how you design your assessments to make sure that they grasp that.
Yes, that we're not real excellent on yet. You know, assessing curiosity, connections, and value creation is challenging. But when you're on the force calculation, it's pretty straightforward. But in some of the other ones, we're hoping as faculty look at these, faculty will help us with that aspect. So it's not very robust at this moment. I'm sorry.
But the idea would be to induce more curiosity.
Yes.
All right.
Yeah, we hope that the stories and all the different things come up would enhance curiosity just from, because when you know any project done in the real world has all these other issues, and it's not as clean and cut and dried as you know, things we put in the textbook.
Well, then I'm curious about how you approach the case studies and present them. And so I can imagine there's an aspect of storytelling, but like, here's somebody who's like you, who's facing this problem to solve. I wonder if there's some some design principles that you have and how to capture and communicate the case studies.
To capture and communicate.
Yeah, so how do you, when you go into capturing a case study, what are the points that you're trying to hit, or how do you develop or co-develop with the person that you're talking to some cohesive thing to record?
Yeah, so we have a pre-meeting with the individual, and we develop from that pre-meeting, we develop a whole series of interview questions. You know, and they always begin with, tell us about yourself, right? And some of the backgrounds of these people are amazing, but tell us about yourself and how you got interested. And then we move into the more, you know, what was the genesis of the idea for this innovation? You know, like in the all-wheel drive, it was very interesting because Steve Christini was working in a hobby shop, and he was working on large remote controlled helicopters. And remote controlled helicopters, the back rotor is powered, it's slave driven from the main big rotor. And that sparked in him a connection with, wow, I wonder if I can drive the front wheel off of the back wheel of a bicycle. And that connection led him to the all-wheel drive bicycle, which led to the all-wheel drive motorcycle. So I'm hoping that we can get some faculty to check these out, the case studies, and give us feedback. You know, here's how I used it in my classroom. Here's what I would like to do. Here's what I would suggest moving forward. The other thing we're really hoping is that faculty might know someone who's an entrepreneurially minded engineer that has a really cool story to tell. It would be of interest to students. And we're very much looking for those. Our naive approach in the very beginning was, let's work with industry. This is a great way to get industry in front of our students in front of industry. But our challenge has been that most companies, once the lawyers catch wind of it, it's all shut down, because, you know, it's not that they're really sharing intellectual property, but they're showing their approach to R&D. And most companies don't want to share that, even though to me it's not that much, it's not really a trade secret. But
So Ken, the feedback on the case studies, you want that to go through the cards on EM Unleashed?
I'll take it any way I can get it. I'll take direct emails. It can go on the card.
Okay.
If it goes on the card, that's probably the most efficient, because then I get emails anyway.
Okay.
But I'll take it any way I can get it.
Questions popping up in the chat, Micah? Or is that?
No. I just put a link in the chat directly to the case studies listed on the Engineering Unleashed website.
Oh, great.
I'm not sure. You can probably browse some without creating an account, but you could create an account and probably see more.
Yeah, if you don't create an account, you won't have access to very many of them. That's for sure.
So we're about out of time. So Ken, thank you very much for sharing with us your work. I think that there's a robust number of people who joined in across the campus, and we're starting to grow people who are into Keen and engaged in Keen across our campus. So thank you everybody for dialing in. Ken shared a couple of cards on Engineering Unleashed. You could certainly browse some and see what is relevant to your teaching interests. In the spring semester, we'll have some workshops where we'll help you capture the cool teaching innovations that you do in your classroom and turn those into cards to share back with the Keen network. All right.
And if anyone has any ideas, I'm all ears for new case studies and how to improve the process. So.
All right. Thank you, everybody.
All right. Thanks, Ken.
Thanks. Take care. Appreciate it. Happy Friday.